Well, hello everybody. We are moving along in our exponential function section. We are in chapter 7, section 7, and we're getting more into detail on these exponential functions. As you see, we're going to dive more into what does B actually mean. I know that we talked about its growth or its decay, and when we have a table of values, we're able to figure out what that common ratio is, but what is it? It's usually a percentage of something, or they give us a percentage and we need to turn it into that growth rate or that decay rate. And so that's what we're going to do today. So when we see a problem and we have a number that's in that spot of B, we are able to tell if it's growth or it's decay simply by looking at it. If B happens to be a number that is greater than 1, it's considered growth. If when we look at B, it's less than 1 but greater than 0, it's that somewhere in between. Less than 1 but greater than 0, it's a decimal of some sort of a fraction that's less than 1. You're going to notice that that is our decay. That's how you can tell the difference. So less than 1 but greater than 0, it is decay. And if it's greater than 1, it is growth. Of course, A is the initial value. Now, when we go to calculate this, the growth rate, okay, how do we get a growth rate? Let's say, for example, they're telling us here that we're putting money in the bank and it's going to grow at a 5.2% each year, right? That's not what we put in for B. We have to take that and turn it into the growth rate. So when you look at this, so this factor of growth that we're dealing with here, in order to calculate it for growth, we have to take the percentage and first off turn it into a decimal. So we have to turn it into a decimal. So first off, in order to take this and turn it back to a decimal, right? Here it is as a percentage. We need to turn it to a decimal, so we need to move the decimal point 2 spaces to the left. 0.052. And we need to add that to 1. Right, so what do we end up with? Our growth factor is 1.052. Great. This would be like A times 1.052 raised to the power of X. That would be the B. Sometimes they want you to go backwards. So what do we do to make it go backwards? Subtract 1 from it. We subtract 1, we're left with 0.052. We can then take this, move the decimal spot back 2 places, and like that, we have 5.2%. You can go back and forth depending on what they ask you. They may give you a problem, ask you to say identify, is it growth, is it not growth, and then turn it back into its percentage. Or they may say, hey, this problem, the bacteria is decaying by 3%. And then you're going to have to calculate that B to be able to use it. Let's take a look at one of these. Maybe that's decay over here. Okay, so decay. Let's say they're going to say, like I just said, you have something that's decaying at a rate of 3%. Okay. First thing, you have to turn it into a decimal. So that means we're going to take this decimal point, we're going to move it 2 spaces to the left, and we have to subtract it from 1. So 1 minus 0.03 equals 0.97. Notice it's less than 1, greater than 0. That would be your decay factor. Now, if you wanted to take that and turn that back into your original spot, you're going to take 1, you're going to subtract 0.97 from it, and that would give you 0.03. Move your decimal spot. And like that, 3%. So we have the ability to move forward and move backwards, just depends on what we're doing. Okay? Let's see how this starts to work. We're going to see these problems. They want to know, is it growth? Is it decay? What is that rate? What is the growth factor or the decay factor that we're dealing with? And then they want you to solve it. Okay, so let's look at the first one. Joe put $1,200 into an interest-bearing account, earning 4.6% interest a year. How much will he have after 5 years? So it's putting that much into an account. It's earning that percentage of interest, and it's 5. Well, I know, right? Hopefully common sense tells us that when we put money into a bank, we expect it to grow. So we need to turn 4.6% into a growth factor. So it's going to be 1 plus 4.6% as a decimal. So move the decimal spot over to 0.046. So that equals my B. What was our initial value? Our A. A is 1,200. Our unit of time, X. How long is this being compounded for? It says 5 years. We're ready to put this into our calculator and go. Let's write it as an equation first, though, so we can see, right? So Y equals A is your initial value, which is 1,200, times 1.046 raised to the power of 5. And what do we want to do first? You have to be careful. Order of operations. Do this part first in your calculator. 1.046 raised to the power of 5. All right. That number's in your calculator. Don't mess with it. Now hit the multiply times 1,200. And one fell swoop, we get to calculate it all. We have $1,502. As we're dealing with money, we want to round to 2 decimal spots. 0.59. Right, that makes sense for us for rounding because we're dealing with money. Money has 2 decimal spots. There you go. Pretty simple. Let's look at another one. The population of the pigset bird has diminished each year by 2.1%. There's an important number. How many of the 12,000 flock will be left after 7 years? Nothing is done to stop this.
Teachers and students, as we get ready to dismiss, I do have a couple announcements. I'd like all the seniors to please pay attention. Seniors, just a reminder that there is a mandatory grad bash meeting on Thursday, the 24th at 2:05. It will be in the auditorium. Please make sure that you attend that meeting. It is a mandatory meeting. We'll be going over plans of what's going to be going on for grad bash, and please make sure that you are there. Also, students, juniors, and seniors, prom is coming up. You do have until April.
Sorry for that interruption, guys. Couldn't get the mute button fast enough. Anyway, fast forward through it. Ready? So here's our setup. We need to set it up. First thing is this is diminished. Diminished means that we are going to be doing a decay rate. So decay rate, we need to first take this, turn it into a decimal. So if we turn that into a decimal, we remember we have to take our little decimal point, move it 2 spaces to the left. That's 0.021. And subtract that from 1. So 1 minus 0.021 is 0.979. That equals our B. Well, how many birds did we start with? What was our initial value? Originally, 12,000. And X, our unit of time, 7 years. All right, so as we sit here and we start to look at this, we're ready to start putting it together. So Y equals, our initial value is 12,000. Our growth factor, our common ratio, however you want to look at it, 0.979. That's being raised to the power of 7. So now we're going through calculator. We put this in our calculator first. Order of operations is do your exponents first. So 0.979 raised to the power of 7. Now you do times 12,000. And after 7 years, there will only be 10,343 birds left. Make sure that you round to the nearest whole number. Nobody wants 0.3 of a bird flying around somewhere. So please be careful that when you're doing real world problems, you carefully read the problem, carefully estimate wherever it's going to. All right. Get out there, try these problems. They're not that hard. The best spot to practice is make sure you understand how to calculate this rate. If it's decay, like it says up here, if it's decay, you take 1 minus the percentage as a decimal. If it's growth, it's 1 plus the percentage as a decimal. And of course, you can reverse that to get back to the percentage of change if you needed to. All right. Have a great day, guys. Get out there and get that homework done.